Here's problem number 5, and what we're going to do is use the Wilcoxon rank sum test to test the claim that there is, to see if there's a difference in the number of credits transferred as opposed from a community college to a four-year school. Okay, the credits that you have from a community college compared to the credits you have from a four-year school when you go to transfer them somewhere. Okay, is there any difference? Well, first thing we do is we arrange the data in ascending order, and then we have to rank everything. Okay, you gotta keep track of which one is from the community college and which one is from the four-year school. Okay, so I'm going to do that over there. You see, this is from the community college, that's from the four-year school. Okay, so now when we arrange these in ascending order, the 35 is the smallest, it's from the community college, then the 37 is next, it's from the four-year, 42 is from the community college, and on and on. And we keep doing that until we have all of these values. Now, we have the same sample size for both. It's 10. So we have 20 data points, okay? And then we rank these, okay? The 35 is the first one. The 37 is the second. Then the third, fourth, fifth, sixth. Now, we have two of the same here, so 7.5. And it's not 7 and 8. Those will be each 7.5. And then that happens again up here. We have a 63 here and a 63 here, so those won't be 13 and 14. They'll both be 13 and a half, okay? And then we can come over and finish this all up. Now, if we do the sum of the ranks, okay, usually we'll do that for the smaller sample size, but here they're both the same, so we'll do either one. If we sum up all the ranks, we get 98 here. If you add the 35, the 42, the 48, all these ranks, add these all up, you get for 98. And then if you add the 37, the 45, the 46, 58, add all these, then you get the 112. Now, it really doesn't matter which one you use. You see, you are able to use either one because the sample sizes are the same here. And so, anyway, we go on down. Now, we write our hypotheses. The null says there is no difference. The alternate says there is. So, this is a two-tailed test, okay, just the way we used to do these. And we have alpha 05, so we use the z-table to find that our critical value is plus or minus 1.96 because it is a two-tail, okay. And then what we have to do is compute our test value. In order to do that, we need mu sub r, sigma sub r, and then we also need r, which we have already calculated. R is either 98 or 112. We'll get the same result with just a sign change, regardless of whether we use which one of those. Okay, either way. So now, we do the calculation. N1 is 10. The size of the first sample, the smaller sample, there's no smaller sample here. They're both 10, so each N1 is 10, N2 is 10. Okay, and then here, for this, 10 times 10 times 21, because 10 plus 10 plus 1 is 21, divided by 12, take the square root, we get 1323. Over here, when we did this calculation, we get 105. And so we have our calculation here, okay? The test value formula, okay, is right here. It's capital R minus mu R over sigma R. So we had either 98 or the 112. Let's take the 98, okay? And then we had the mu R is 105. We had the sigma R. Calculate that out, you get negative 0.52910. Okay, and that's over here. Okay, that is not in the rejection range below or the rejection range above. Therefore, we do not reject, and that's how we get the answer. That's how we use this test to arrive at the conclusion that we do not reject, and that's the answer to problem number 5.